you've got a friend in me, unless of course you're one of the other teams that we are trying to compete against. We are the Flaming Fives, which is composed of Austin Guys, Jesse Phillips, and Garrett Schuler from Section I, Team 5. We are an elite task force of toys who are given the assignment to combat the diabolical Sid. Sid has captured the fearless Space Ranger Buzz Lightyear and several more of Andy's beloved toys. Our mission was to construct an autonomous robot that could rescue our fellow toys and return them to Andy before he heads to his new home. Our robot had to rescue Buzz from a circle without disturbing the aliens surrounding him, return 3 RC cars to the appropriate colored region of the moving truck, give Andy his toy back in his minivan, and assist our Space Ranger in launching a rocket to a height of at least 42 inches. Each of these tasks were worth a certain number of points, and ultimate victory would be achieved by completing all 4 tasks and maximizing the points scored. This video will discuss the steps taken to design our mission robot and its success in rescuing our fellow toys. Before we began to design our robot, we first created a house of quality to analyze the customer requirements and see how they relate to specific engineering requirements for the robot. Some of the highest rated requirements were fit and go no-go box, activate, robot moves off start, and remain within specified zone, as each of these had to be addressed to avoid disqualification in the competition. The engineering requirements of average score, delivery success rate, and time to complete task had the highest importance ratings. They addressed the most customer requirements, thus optimizing them will result in more customer requirements being addressed. Several specifications were created to address the engineering requirements, and the values highlighted in red were specifically tailored towards the highest rated engineering requirements. We intended for a robot to be 22 by 10 by 16 inches in size in order to fit within the go no-go box. Along with this, we aimed to score 149 points per round 90% of the time. This point value was selected because it accounted for each of the tasks that we had direct control over. The depositing car task could be interfered with by our competitors, thus we could not fully control its outcome and its point values were not included in our target value. The robot has to complete several functions in order for it to complete its mission. Each of these functions are listed in the function tree. The tasks for the competition were broken down into sub-functions that addressed each step the mechanisms would have to accomplish to complete their task. For each of these sub-functions, a physical mechanism could be designed to accomplish it.
With the morphological chart, the functions that needed to be accomplished were turned into multiple mechanisms that could be used in the manufacturing process. For the Buzz set of tasks, the robot was chosen to roll over the block and use a slapper to knock him out of the starting area. Lifting the rocket had 2 equally scored designs, including a scissor lift and extending drawer slide. When delivering the balls, the carrying slot will be lifted to an increased angle, allowing the cars to roll out and into their designated slot. As for ball delivery, it will be stored in a cylinder, lifted by an arm which will reach over the drop zone. Once in place, a pin will be pulled to release the ball. For the first competition, only 2 tasks were required. This is the lifting of the rocket to 42 inches and the removal of Buzz from the starting circle in which he begins. The way we accomplished these were chosen directly from our morphological chart previously mentioned. To lift the rocket, a scissor lift will be used. There was a bolt through the bottom, which when turned would close the legs and lift the rocket. This bolt would be spun with the same motor used for aggression. The plan to move Buzz included a mousetrap attached to the bottom of the rocket. This mousetrap would be triggered by a solenoid to hit Buzz in the general direction he needed to go. The first competition design was definitely a learning curve for the entire design process. An hour before the first competition, we began testing and realized the motor did not turn fast enough to raise the scissor lift, and the nut which the bolt tightened onto slipped out of the wood. The mousetrap also did not trigger as the solenoid did not have a long enough pull to it. With this said, we earned 37 points during each of the 4 rounds of Competition 1 by launching and not hitting any aliens. For future consideration, more design preparation and planning should be made. The complexity of the system was highly underestimated, and testing should begin a few days in advance of the competition, not an hour in advance.
We learned a lot from the mistakes we made in the first competition. The biggest mistakes we made were depending heavily on manually cut wood and poor planning before starting to build. One thing that we noticed worked well from the first design was the laser cut gearbox. The laser cutting fabrication approach allowed for a much smoother transition from CAD to reality. After taking all of this into account, we decided to meticulously plan the robot in SOLIDWORKS and then depend heavily on laser cutting and 3D printing for fabrication, minimizing the human error. We also noticed some significant flaws in the scissor lift design. It took up too much space and was difficult to lift. Because of these problems, we decided to transition to a drawer slide cascading lift that we observed working successfully for other groups. This is the new design made in SOLIDWORKS. It uses interlocking wooden pieces to assemble and can be nearly entirely made from laser cut wood. It features a two-stage drive system where the motor both spins an axle to lift the rocket and an axle to spin the wheels. Our goal was to use one motor to both lift the rocket and egress so that we could save a motor for other tasks. The building process for this design was much easier and we had no significant problems assembling the robot. However, once we began testing, we realized that the spool we made to lift the rocket wasn't large enough and would take too long to lift. To fix this problem, we were forced to use our remaining motor to power the lift. Another problem we encountered was inconsistency in our buzz retrieval mechanism. Because of this, we elected not to use it in the competition, instead to tape a wedge to the front of the robot to both push Buzz and an alien out of the circle. In the interim competition, our robot egressed and lifted the rocket every time. We successfully deposited cars in 3 of the 4 runs and removed Buzz from the circle in 2 of the runs, for an average score of 96 points. We also placed second in our section. In the second competition, we learned that the changes we made were effective, and that using laser cutting is the way to go. We also learned that we needed to test and improve our buzz mechanism more, and also adjust the spool so that the one motor system will work. Taking what we learned from the second competition, we finished designing the robot. We incorporated an arm that would be laser cut and powered by a motor. This arm would drop the ball in the center and could be made from laser cut wood. We also fixed the spool issue and left time to test the buzz retrieval mechanism. This is the final result.